Hi everyone, in this video I am going to talk about the concept of Poisson random variable or Poisson distribution. Poisson random variable. Poisson random variable. Its definition is the number of events determined by random process during an interval of time or space. Or in another word is what is the probability or what is the chance that you get a certain number of events within an interval of time, a range of time. Okay. Let me give you an example. Example is the chance that you get one spam call. One spam call in the next 24 hours, right? What is the probability or what's the chance that you get a spam call in the next 24 hours? Or one customer buys a toy from your toy shop in the next hour. Okay, so in this case, we're looking at the time interval is from now to the next hour, and then the event is that one customer buys a toy. Okay. To talk about Poisson random variable, one parameter that's very important is lambda. Okay. So lambda is the rate of happening, or is the average rate of happening. Okay, so it's the average rate of happening. Say, let me give you an example. Lambda equals to 2 spam calls. 2 spam calls in a day, right? So on average, people are getting 2 spam calls in a day, right? One day, average 2 spam calls. When we work with lambda, one thing you need to pay really close attention is the unit. So units of lambda are very important. Okay, I'll show you in the next example. Units are important. Good. Okay, so we have the parameter, and now let me give you the formula for a calculation. Okay, so it's the Poisson. Poisson. Okay, Poisson probability distribution. Okay. So in this case, let's say we want the probability of x, the random variable, equals to a certain realized value that you want. And this equals to e raised to the power of minus lambda times lambda raised to x over x factorial. So again, lambda is the rate, and then x is the number of events happen. Okay, cool. Let me go ahead and give you an example to solve or to apply this formula. Okay. The example, in this case, lambda equals to 2 spam calls in one day. Okay, so you're getting 2 spam calls in one day, and then the question we want to ask is, what is the probability of getting 0 call or 0 spam call in the next hour? Okay, let's get back to the note I mentioned that units are important. So the rate you're given looks at how many spam calls in one day, but what we want is in the next hour. So we have to convert this unit into the unit we can use in the question. Okay, so let's give the name lambda nu. That's equals to, so you get one day you get 2 spam calls, and then there are 24 hours in one day, and that's equals to 1 over 12 call per hour. Okay, so on average you're getting 1 over 12 call per hour. Now we're ready to apply the formula here. The probability of x equals to 0, so you're getting 0 spam call equals to lambda x over lambda x factorial, right? So instead of multiply this by e raised to negative lambda, I can switch down and then take away the negative here. And this equals to lambda, so 1 over 12, x equals 0 over e raised to 1 over 12 and 0 factorial. Let me make a note here, right? So 0 factorial, let me do it here, 0 factorial equals to 1. Okay, and then this equals to 1, because anything raised to 0 is just equals to 1 over e1 over 1 over 12 multiplied by 1, and this is approximately equals to, so you have to use a calculator for this, 0.92044, right? So about 92% probability that you'll get 0 spam call in the next hour. Okay, let's do this again, but let's change the number of x. So now, let's say instead of getting 0 call, the question becomes getting 1 call in the next hour. Right? What's the probability of getting 1 call in the next hour? So we're going to apply the formula again. X equals to 1, and that's equals to 1 over 12 lambda raised to 1 over e raised to 1 over 12. That's 1 factorial. That's equals to 1 over 12 over e raised to 1 over 12 times 1. And then that's approximately equals to 0.07667. So it's about 7.667 probability percent that you'll get a call in the next hour. Okay, good. Okay, let me give you the related parameters of Poisson random variable. Okay, so parameters of Poisson random variable. Okay, so the mean or the expected value of Poisson, or let me just put x instead, equals to lambda, right? Just one parameter. And then the variance of x goes to lambda, and then the standard deviation of x is again equals to, or is the square root of lambda. Okay, this video talks about the concept of Poisson distribution, Poisson random variable, and thank you for watching, I'll see you in next video.